Hi everyone, let's go ahead and get started with npinf and npinf. So the nan is not a number, inf is infinite number. So when numpy says that this is not a number, that's mean for a numpy it is unknown data type. And when it is inf, that means for a numpy it is some value which is beyond the calculation, that means which is infinite. All right, and you cannot compare these nan values together, but you can compare these inf values together. Logically this doesn't seem correct, but that is how numpy works there. For example, if I say here np.nan, you see there it says that this is not a number. And if I take two numbers np.nan, I compare these numbers, it says that these are false. That means it is saying here these two numbers are not equal. Otherwise you can take it something like this: a equal to np.nan, b equal to np.nan. You print here a and b. Now you see here both numbers are nan, and if you compare here a equal to b, you will get here a false, or whatever the comparison you put here, you will get the false, because this cannot be compared with each other. Let's go ahead and see how we can compare np.inf together. I get here a equal to np.inf, b equal to np.inf. Then I say here a comma b. It is saying that these two values are infinite. Let's go ahead and compare these two values. I say here a equal to b. It says that it is true and a greater than b is false. So what happens here in numpy, when it is inf value, then numpy says here you can compare these two values together but not the nan. There is another data type in the numpy which is none data type. This one is also a data type in numpy which is none. You check here, the type of none is none type. You can also compare these none type to each other. For example, n is equal to none, none equal to none, that means it is a true. You cannot say that none is greater than none. Alright, so there is just equal to operator. It does not support greater than or less than. It only supports here equal to, which says that it is a none there. Let's go ahead and create a two-dimensional array here. A equal to np.array. A two-dimensional array is a vector of a list of one-dimensional array. That means I'm going to say here 1, 2 and 3, and then I say here 4, 5 and 6. Now you see there a dot shape is 2 cross 3, that's mean 2 rows and 3 columns are there into a, which is a two-dimensional array. Now I'm going to replace here these two values with the inf and nan number. That means I need to say here a 0 1. Alright, so I'm going to say here a 0 1, that's mean I'm saying this value equal to np.nan. Then I say here a 0, that's mean this one, and then this value. I say here 0 and then 2 equal to np.inf. So it says that cannot convert float nan to integer. So what happens here, the array which we created earlier, the data type of that array is actually the integer. So we need to convert this data type to a float data type. Now it becomes here a float. Once it is a float data type, then you can assign here np.nan and np.inf. Now I get here a equal to nan and inf. If you compare this a with inf or nan, you will get here a true value, but not here. So to do that, just to check that the nan values or a null values, you can write here np.isNan, and there I say here array a. So it says that this value is nan, and that's where it is saying that here a true, and rest it is saying that it is a false there. All right. Similarly, you can check here np.isInf, and in that I pass here array a. Again it says that these are these are false and false, and then here it says that the true. Then here it is false, false and false. All right. That means I said here isInf. It will give you a true value where the value of the array is inf. Alright, this is all about in this lesson. Thanks a lot for watching this. I'll see you in next one.